teammates are Priya, Meghana, and Suma. Our topic is IPL T20 Database System. Explanation the index page, which includes part 1 and part 2. Description of the design choices and relationships. In designing the IPL T20 database system, careful consideration was given to the both conceptual schema and the logical schema. To ensure accurate presentation and efficient handling of real-world data, it includes design choices such as key entities and attributes. Key entities includes core entities like team, player, match, stadium, and tournament, were identified to represent the essential components of the IPL system. Attributes. Attributes include meaningful attributes were selected for each entity, such as player name, team name, match date, runs scored, etc. To capture all the relevant data without redundancy. Normalization, which includes the schema was normalized to eliminate redundancy and ensure data consistency, allowing easy updates and maintenance. Data types, which includes appropriate data types, for example, int, varchar, date, etc., which were used to optimize storage and maintain data integrity. Relationships. Relationships between entities were defined based on the real world interactions, such as a player plays for a team, a match is played between the two teams, a match is held in a stadium, and a tournament consists of multiple matches. Cardinality constraints, that is, one to many and many to many, were used where necessary to reflect real world scenarios accurately. Here, primary and foreign keys are ensured relational integrity across tables and supported efficiently querying. This comprehensive design not only supports the current requirements of IPL database management, but also allows easy scalability for future extensions like adding player states, team rankings, or historical performance. IPL T20 database system was designed to effectively capture the complexity of the IPL T20 database system was designed to effectively capture the complexity of a tournament environment. It includes players, teams, matches, auctions, umpires, and venues. Here's a breakdown of the design choices and relationships used. Design choices, which includes key entities, attributes, data integrity, etc. We identified the core entities crucial to IPL operations, which includes team, player, match, stadium, auction, performance, and season. These entities represent real world objects and are modeled as rectangles in ER diagram. Attributes. Attributes which include each entity includes relevant attributes. Relevant attributes such as team ID, which is a primary key, and team name, owner name, and coach name. Player. Player attribute entity includes player ID, which is a primary key, and player name, nationality, and date of birth of a players. These are represented as ellipses in the ER diagram and help us to describe entity characteristics. Data integrity. Data integrity, which includes primary keys, foreign keys, and etc. Primary keys are uniquely identified records in tables. For example, player ID and team ID. Here, foreign keys helps us to maintain relationships like each player is linked to a team. These constraints ensure referential integrity, relationships between primary and the foreign keys. A team has multiple players. A player can participate in multiple matches. A match takes place in a stadium, and auction links players with teams. Performance records track how players perform in matches. Each season consists of multiple matches and auctions. These relationships are depicted as diamonds in the ER diagram and help reflect real world interactions between data elements. Summary. This database design ensures that efficient data storage and retrieval, clear entity relationships, logical and conceptual consistency, easy scalability for additional IPL features in the future. Based on this explanation, which includes design choices and relationships in IPL T20 database. This includes design choices, that is, entities and attributes. Entities were chosen to reflect the real components of the IPL ecosystem. Each entity is well structured with meaningful attributes. Attributes which includes match, stadium, auction, performance, and season. Match. Um, Match attribute which includes entities like match ID, which is a primary key, and match date and season ID, which is a foreign key. Stadium. Stadium includes stadium ID, which is a primary key, and stadium name, city, country, capacity, etc. And auction. Auction includes auction ID, which is a primary key, player ID. Player ID is a foreign key. It also includes team ID, which is also a foreign key, and price status. Status means the sold and unsold of teams. Performance. Performance includes match ID. That is a foreign key, and player ID. Foreign key, runs scored, wickets taken, catches, etc. Season. Season includes year, start date, end date, etc. Year, start date, and end date. Relationships between their descriptions. The relationships define how entities interact. These are represented as diamonds in the ER diagram. Player. Player belongs to the team. Through participation in a specific season, team plays match. Two teams are linked each match. Player. Player participates in match. Tracks which players took part in match. Next, player has performance. Records individual performance in matches. Player is bought in auction. Links players to teams and prize in auction system. Match. Match is a part of season which connects each match to a particular season. Player plays for the team in season. It also establishes the seasonal participation of the player in the team. Conclusion. This database schema ensures a robust and flexible design for managing IPL tournament data. The structure supports easy tracking of player statistics, match histories, and team compositions, auction results, and season details, all while maintaining relational integrity and clear entity relationships. Here comes cardinality constraints. Cardinality constraints define how many instances of one entity can be associated with instances of another entity. These help enforce data integrity and guide relationship design. Examples for cardinality are player, player and team. For example, the relationship between player and team is M is to N. For example, a player can play for multiple teams over different seasons, and a team consists of many players. Second one, match and team. The relationship between the match and the team is 1 is to M. That is, each match involves exactly two teams. A team may be involved in many matches. Next example is match and stadium. The relationship between match and stadium is 1 is to M. That is, a match occur in one stadium. A stadium can host multiple matches. And player and auction. The relationship between player and auction is M is to N. A player can be bought in multiple auctions. Player to auction. The relationship between player and auction is M is to N. That is, a player can be bought in multiple auctions, and an auction can have multiple terms. Next example is player and a performance. The relationship between player and a performance is 1 is to N. That is, one player for one performance. A player that has one performance for record per match. Now I am going to explain about ER diagram with notations. The ER diagram graphically represents the entities and relationships and attributes using standard notations. For examples, a rectangle which indicates the entities. For example, team, players, match, auction, performance, and stadium. Diamond shape. The diamond indicates the relationships, that is, includes, plays, takes place, generates. Next one is ellipsis. Ellipsis indicates the attributes. For example, team ID, player name, match date, stadium name, runs, etc. Next one is double ellipsis, which indicates that multi-valued attributes. For example, not shown here but standard in ER. Next one is lines and connectors, which indicates that link entities and relationships. That is, relationships such as M is to N, 1 is to M, 1 is to N. That indicates that these relationships represent the cardinalities. Diagram highlights is team includes players, that is, M is to N. Next one is includes match, that is 1 is to M. Match takes place in the stadium, that is 1 is to M. And the player is bought in auction, that is M is to N. Match generates performance for each player, that is 1 is to N. Purpose of ER diagram is, this diagram visually maps the structure of the IPL database system, helping users understand how different entities interact. It aids in visualizing relationships, determining foreign key placements, structuring logical and physical database schemas, etc. Next slides will be continued by Kusmar.
Part 2. Next, logical schemas. First one, team. Relational schemas are team ID, team name, owner name, and coach name, and home stadium ID. Primary key is the team ID. Foreign key is the home stadium ID. Define data types and ensure sequential integrity. MySQL. Create a table team. Team ID is the int and also a primary key. Team name varchar. Size is 100. Owner name varchar. Size is 100. Coach name varchar. Size is 100. Home stadium ID is the int. Foreign key is the home stadium ID. Dif- reference uh, stadium reference stadium ID. Next, sample records. This is the table. uh, Insert the values in the table. Next is the player. Relational schemas. Player ID, player name, nationality, and date of birth. Primary key is the player ID. Define data types and ensure the sequential integrity. MySQL. Create a table of player. Player ID is the int and also a primary key. Player name is the varchar. Nationality is also a varchar. Date of birth is date. Bracket close. Next, cards. This is the table. Insert their values. Next is the match. Relational schema. Match ID, session ID, team ID, stadium ID, match date, and winner team ID. Primary key is the match ID. Foreign key is the team ID, winner ID, session ID, and also a stadium ID. Define data types and ensure sequential integrity. Create a table match. Match ID is the int and also a primary key. Session ID is the int. Team ID is the int. Stadium ID is int. Match ID is match date is the date. Winner team is the int. Sample records. This is the table. Insert their values. Stadium. Relational schemas. Stadium ID, stadium name, city and country, and capacity. Primary key is the stadium ID, data types, and ensure sequential integrity. MySQL. Create a table stadium. Stadium ID is the int and also a primary key. Name is the varchar. Size is 100. City is the varchar. Size is also 50. Country is the varchar. Capacity is the int. This is the sample records. Insert in the value. Actions. Relational schemas. Action ID, session ID, player ID, team ID, price and status. Primary key is the action ID. Foreign key is the session ID for player ID and also team ID. Data type and ensure sequential integrity. Create a table action. Action ID is the int and also a primary key. Session ID is the int. Play, player ID is the int. The decimal. Status is virtual. Sample records. This is the table of actions. Insert the table values. Performance. Relational schemas are the match ID, player ID, run scores, wickets taken, catches, sixes, strike rates, and dot balls. Primary key is the match ID and player ID. Data type and ensure sequential integrity. MySQL. Create a table of performance. Match ID int. Player ID is also int. Run score int. Wickets taken int. Catches int. Sixes int. Strike rates also int. Dot balls is int. This is the sample records. Insert in their values. Next will be continued by Priya.
Then I am going to continue the season tables. Relational schema, season ID, year, start date and the end date are the attributes of the season table. And primary key in the season table is the season ID. Data types and ensures the sequential integrity. This is the creation of the season table. And next is the sample records of the season table. Next is the player team season table and the relational schema are the player ID, team ID and season ID. Retained are the attributes of the player team season table and player ID and season ID are the primary keys of the player team season and data types and ensures the sequential data integrity. And this is the creation of the player team season and player ID, team ID, season ID and the retained boolean. These are the attributes of the player team season table and next is the sample record of the player team season. Next will be the match table and match ID, match date and result. Stadium ID, these are the attributes of the match table and match ID is the primary key in this table and stadium ID is the foreign key in this table and data types and ensures the sequential integrity and selects the match ID, match date and team 1 and 2, winner team ID and result season ID and from the match. Next, this is the sample record of the match table. These are the queries and match and team performance queries. Highest scoring match and select the match ID maximum of the team 1 score plus team 2 score as the total score from the match. Uh, Next will be give the match ID and the total score. Second, lowest team total in this match. Select that first team ID. Next, minimize the total marks from the match performance and group by the team ID. Next, team that lost the most wickets in a match. Select the team ID. Next, match maximum wicket lost from this match performance and group by the team ID. Team with the most wins at a specific stadium. Select ID count from the match where the stadium ID is equal to 1 and group by winner ID. Next is the best win percentage and select the count star from the match where the team ID is equal to the winner ID or team 2 ID is equal to the winner ID. Specific stadium. Select the first winner team ID. Next will be the count star from the match where the stadium ID equal to the 1. Next will be the group by the winner team ID. Next best win percentage. First will be select the winner team ID. Next the count star 100. Next select the count star from the match where the team 1 ID, winner team ID and the team 2 ID. Next, winner ID as the win percent from the match group by the winner team ID. Scroll mode for player performance queries. First player with the most sixes. First select the player ID from this player table and some sixes from this performance. Next group by the player ID and order by sum of the sixes and desk limit is the 1 and player ID is equal to the 7 and sixes are the 357 will be the output of this queries and player with the most runs in a single season. First, I will select the player ID. Next will be the season ID and sum of the runs from this performance and group by the player ID. Next, season ID. Next will be the order ID, sum of the runs. Desk limit is equal to 1 and the player ID is equal to the 18 and season ID is equal to the 2006 and runs are the 973 is the output of this queries. Next is the player with the most wickets. First select the player ID. Next is the sum of the wickets from this performance and group by the player ID. Maximum wickets desk limit is equal to 1 and player ID is equal to the 25. Wickets are the 183 are the output of this queries. Next bowler with the best bowling in a match. First select the player ID. Maximum wickets from this performance group by the player ID. Player ID is equal to the 50 and wickets are the sixes is the output of this queries. Next is the batsman with the highest strike rate in a season. First select the player ID and the season ID. Next will be the average of the strike rate from the performance. Group by the player ID, season ID. Order by the average of the strike rate and desk limit 1. Player ID is equal to 33 and the season ID is equal to the 2019. Strike rate will be the 2204.82 is the output of this queries. Next is the stadium and the ground analysis queries. First, stadium with the most IPL matches. Select the stadium ID and count star from the match. Group by the stadium ID and order by the count star. Desk limit 1 and stadium ID is equal to 1 at 1 and matches are the 92 is the output of this queries. Next is the stadium with the most 200 plus scores. First select the stadium ID. Next will be the count star from the match where the team 1 score greater than the 200 or team 2 score greater than the 200. Group by the stadium ID. Stadium ID is equal to 1 or 2 and 200 plus scores is equal to 25 is the output of this queries. Average first inning score at a ground. First select the average of the team 1 score from the match where the team ID is equal to 1. Average score will be the 167.3 is the output of this queries. Team with the
ಈಗ ಅದು
best
ವಿಡಿಯೋ
win
ಬರ್ತೈತಲ್ಲ
record at a
ಡಿಟೇಲ್ಸ್ ಯಾವಾಗ
stadium. First select the winner team ID. Next will be the count star from the match where the stadium ID equal to the 1. Group by the winner
ಅದನ್ನ
team
ಫೋನಿಗೆ
ID.
ಹಾಕೊಂಡು ಯೂಟ್ಯೂಬಿಗೆ ಹಾಕ್ಬೇಕು.
Order by the count star. Desk limit 1. Team ID is
ನಮ್ದೇ
equal
ಅಕೌಂಟ್
to 3 and
ತೆಗಿಬೇಕು.
wins are the 23.
ನಂದೇ ಅಕೌಂಟ್
Will be
ತೆಗಿಬೇಕಿಲ್ಲ.
the output of this queries. Thank you. Next
ನಮ್ದೇ
will be
ಅಕೌಂಟ್
continued by the Meghana.
Good evening, myself Meghana. Here are some queries which are historical and trend analysis queries. First one, team with most losses. This query aims to find the team that has lost the most matches. It counts the number of times each team has been the winning team ID, means they won, or loser team ID, means they lost from the match data. Then, then we have to declare these queries. Select team id, count star from select team 1 id as where condition where team id is not equal to the team 1 id. then it com- then it combines these results to find the team with the highest number of losses. For example output is here. Team id is 6, that is Delhi Capitals lost 118 times. Then bowler with most dot balls. This query identifies the bowlers who has bowled the most dot balls. It sums up the dot balls for each player ID from balls statistics. For example, output is 27. Bhuvaneshwar Kumar, who has the most dot balls, that is 1435. Next, player with most IPL matches. This query finds the players who has played the most matches in the Indian Premier League. It counts the distinct ID from performance data. For example, 18 MS Dhoni, player ID with 18, who is played 77 matches. Cap, captain with highest winning percentage. This query aims to identify the captain with the highest winning performance. It calculates the win percentage for each captain ID by dividing the number of wins by the total number of matches played as a captain. For example, captain ID 3, who is Rohit Sharma, his winning percentage is 64.9%. Rohit Sharma has a 64.9% win rate as captain. Next, action price trend for a player. It selects the season ID and price for a specific player ID. In this case, player ID 18, which is Virat Kohli, with from auction date. Example, for Virat Kohli, player ID is 18. In 2008, 18, 17.0, in 2019, 17.0, 2020 also 17.0, 2021, 15.0, 2022, 15.0. Auction and retention queries. Player with highest action price this season. This query aims to find the player who receives the highest action price in the specific season. In the case of 2025, it selects the player ID and the maximum price from the action data from season ID 2025. The example output is player ID with 51. Mitchell Stark was auctioned for 24.7 crores in 2025. Franchises with most retained players from previous season. This query identifies the franchises, that is teams that retained the most players from the previous season. It counts the number of players marked as retained is equal to true for season ID 2025, grouped by team ID. Example output is team ID to Kolkata Knight Riders retained 16. This suggests Kolkata Knight Riders players who changed the most. This query finds the players who has changed their team most number of times across seasons. It counts the distinct team ID for each player ID from the player team season data and order the result to show the player with the highest count first. For example, player ID with 16, Finch, team played 9. This indicates Finch has played in action in last 5 seasons. This query determines which team spends the most money in actions over the last 5 years from 2021 to 25. It calculates the number of prize for seasons between 2021 and 25 and then ranks them by total spending. For example, team ID 5, Sunrisers Hyderabad, total 480 crores. This implies Sunrisers Hyderabad spend 480 crores in auction over the specified 5 season. Next, description of design, choices and relationship. The key entities and their roles. These are like the main categories of information you'd stored in the database. Player. This represent individual cricketers. It would store their Personal details and skills. Team. This represents the franchises like Mumbai Indians, CSK, etc. It would stores details about the teams, matches. This holds information about each game played, such as unique match ID and other match level data. Stadium. This stores details about the venue where matches are played, like the stadium ID, capacity, 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 etc. Action. This track when players are bought by teams, including details like an auction ID. Season. This represents each IPL season identified by the season ID. Performance. This stores individual player statistics from match, such as runs scored, wickets taken each, etc. Match result. This provides detailed information about each bowled and the overall outcome of the matches. Player team season. This is the special table that links players to the team they played for in the specific season, and also track if they were retained by the team. Relationship normalization. Many to many via team season. This is a technical term meaning that the player can play for many teams over different season, and a team can have many players over different season. The player team season table is used to manage this complex relationship. Next, the team to match. Many to many. Here the relationship is many to many. A team can play in many matches, and a match involves two teams. That is many, and a single match involves many teams. Match stadium. Many to one. Many matches can occur at one stadium, but a single match only happens at one stadium. Player to performance. One to many. A single player can have many different performance records according different matches. Match to result. One to one. Each match will have one corresponding result. Who won and the who lost. Design choices. Normalization. Data is normalized to 3NF to reduce redundancy. Here, normalization means organizing the data in the database to reduce duplication. Thinks of it like organizing your files so you don't have the exact same document saved in the multiple folders. 3NF is a specific level of this organization, means the data is structured well to avoid the unnecessary repetitions. His, tracking. Use of player team season allows full tracking of player transfer and retention across season. This means the database is designed to keep a complete record of where each player has played and for which team in every season.
A very
The player team season table is crucial for this. Aggregation support. The schema supports efficient aggregation and common queries. Aggregation means summarizing data. For example, finding the total runs scored by a player. Flexibility. The schema is a scalable and full future seasons, stadiums, or even expand to other T20 league. Flexibility here Flexibility means the data designed in adaptable and can grow easily without needing major changes. Scalable to add future seasons. You can simply add new data for upcoming IPL seasons. You can easily add information about new stadium if they are built or used. Expand to other T20 league. This design is broad enough that it could potentially be used to store data for other T20 cricket league around the world with minimal modification rather than needing to build a completely new database from the scratch for each. Thank you.